All right. Hello, everyone. Miss Bakira here again, and we are on lesson 2 of week 31. So, this is going to be a continuation of understanding how to use our solubility rules in the context of double replacement reactions. So, just to review solubility, it is a physical property, it's the capacity to dissolve in a liquid, and this way we talk about the context of being able to dissolve in water, and that state of matter is indicated by AQ in parentheses. On the right side of my screen, you can see that there is the solubility rules open. If you do not have those open, I would recommend that you open those now. Or on your PowerPoint lesson 2, there is the solubility rules, but once again, I would recommend that you set it up side by side as you see on my screen right now, so you don't have to continuously go back to slide number 2. So let's talk about, first, we are going to be doing predicting products, and then once we predict the product, we are going to identify the type of reaction or the type. We are going to be determining which one is solid and which one is a liquid, meaning a precipitant has formed. So when we are looking at our double replacement reactions, we want to identify which one is our cation and which one is our anion, indicated with these plus and minus signs. Our cations are always first, so Fe and Cu are going to be our cations. Our anions is a chloride and a sulfite, which are a nonmetal and a polyatomic ion, respectively. Next, we know that two positive ions are never going to bond together. We know they're never going to bond together, which tells us that Fe is going to switch partners with Cu, and Fe is going to bond with ASO4, and Cu is going to bond with Cl. So, knowing that, we are going to say Fe subscript 2, SO4 subscript 3. If you are slightly confused how I did that, the subscript specifically, we did talk about it last week. We also talked about it in week 13 through 16. If you need a review of how to determine the formula for ionic compounds, please let me know and I would be happy to send you some additional resources. And then it is going to be CuCl. There's no subscripts there. Once again, if you would like, you can help yourself visualize this by assigning your compounds as with anions and cations. So now that we have this laid out for us, hopefully it will switch slides. There we go. Oh no, I forgot this 3 here. We want to determine what their the states of matter are. Sorry, everyone, my brain, dang. Anyways, so we're going to look at our solubility rules. First, we're going to start with Fe and sulfate. We're going to look down our list. We get to number 4. Rule number 4 states that all sulfates are soluble except for ones shown here. Fe is not an exception, therefore it will be considered soluble. So its state of matter is AQ. Now, when we get to our, oh my goodness, that is not what I wanted. I just wanted to highlight that. CuCl. We're going to look down our list. While we look down that list, we get to our chlorides, bromides, and iodines. Rule number 3 are generally soluble. But then we have to identify that Cu is an exception. Copper is an exception to this rule. So since copper is an exception to this rule, that gives us insight that CuCl, copper 1 chloride, is actually a solid compound. It is a precipitant. So rule number 1 that we used for this process is we use rules 4 and then rule number 3. Hopefully that will type there. Beautiful. All right, so let's go to one more practice together. So here we're looking at slide number 5. On slide number 5, we have potassium iodide and lead nitrates, which both have already been identified as aqueous. So they have already been dissolved and they're feeling pretty good. Now we are going to assign our cation versus our anion. K is a metal. It is positively charged when it becomes an ion. Iodine is negatively charged, therefore an anion. Ag, which is silver, is positive, and our polyatomic ion here is a nitrate, and nitrate is negatively charged. Now I'm going to have them switch partners. So positive replaces positive, negative replaces negative. So we're going to have KNO3 and AgI. Oops. Once again, if it helps you visualize, you can then see that the partners are positive and negative, and they create an ionic compound. An ionic compound, once again, is a compound made up of ions. Beautiful. We are going to now go to slide number 6. In slide number 6, we see that it's already laid out for us. I have accidentally already told you the state of matter of potassium nitrate, which is okay. We can see that because it is in rule number 1 and in rule number 2. Both group 1A and nitrates are almost always soluble. Next, we're going to go on to rule number 3 to identify our second compound solubility. We see that iodines are, generally speaking, they are soluble, but Ag, silver, is an exception to this rule. Since it is an exception to this rule, that tells us that it is solid in water solution. And we can say that we used rules number 1, 2, and 3 to determine the states of matter of the products. All right, we have one more to go together. If you're feeling good about this, you can skip to slide 9, but we'll get to that in a second. Otherwise, stay with me for this last one. We have NaOH. Na is positively charged. Hydroxide is negatively charged. Cu is positively charged. SO4, which is sulfite, is negatively charged. We know that like replaces like, metals replace metals, and non-metals replace non-metals or polyatomic ions. So we're going to have NaSO4 plus CuOH. Alrighty. Once again, I will take a moment and assign those positive and negative charges for you. Now that we have that, we are going to go on to slide number 8. If you would like, just take a second, pause the video, and try to determine the charges, not the charges, the states of matter for the following products. Oh, my computer is about to die. All right, hopefully you've paused your video and now you are ready to chat about this. Na is a group 1A metal. It therefore means that it is insoluble, meaning that it is going to be indicated as AQ. It's aqueous. Next, we have our CuOH. Here, we're going to go down the list. We're going to do a rule we haven't looked at quite yet. It's rule number 5. And in rule number 5, it tells you that these compounds below are insoluble. So hydroxide ions are insoluble. There is an exception to that, which is group 1A and 2A. But copper is in either of those groups. It is a transition metal, which therefore tells us that it is soluble or insoluble in solution, and it is categorized with our S. And the rules that we used is 1, 4, and 5. All right, your job now is going to be doing 6 or 9. Sorry, my dyslexia got me there. 9, 10, and then you're going to do the following practice problems. You're going to be identifying or predicting pairing and state of matter of products. Then there is also an exit slip. This exit slip is going to be also a Google form, and it is going to be considered a check-in. So we're going to look at what does it mean to be insoluble, and is Mg3PO4 is that soluble or not? All right, thank you for your time. I will see you in class on Thursday if you are my B kids, and Friday if you are my A or my VLO kids. See ya.